It's really important when you're working with functions to be able to determine what kind of function you're dealing with. All right. In this half of the year, we focused on linear functions, quadratic functions, and exponential functions. And so this video is to focus on how to tell what kind of function it is. So linear functions have x to the first degree. Okay, so that means that it's just an x with no variable. All right, so some examples might be y equals x plus 2. All right, notice that the highest exponent in here is 1, and the variable itself is not part of the exponent, and it's not the bottom of a fraction. 1 over x, for example, is not linear. All right. Now, if something is quadratic, quadratic functions have degree 2. That means that the highest exponent that you see is to the second degree. So quadratic functions x to the second degree. Now again, that x is not in the exponent, and that x is not in the bottom of a fraction. So some examples, you might have y equals x squared minus 7. All right, that is quadratic. Now, you want to be careful. Sometimes you might see quadratic functions as a factored form, like, oh, my pen is just really not happy today. X plus 3 times x minus 4. So here, if we had written this in standard form by multiplying together these two sets of parentheses, then that would be a quadratic. But it's in the factored form instead of standard form, and so it kind of masks the fact that it's a quadratic. All right, so be careful with quadratics because sometimes it's not quite so obvious. All right, if something is exponential growth, there's two pieces you have to look at. All right, so the growth piece is that the number raised to the exponent is greater than 1. All right. The other thing is it has to be exponential. It has to have x as an exponent. So some examples of growth. Generally you see like y equals a times b to the x is exponential. So you could have like 0.5 times, I don't know, 7 to the x. All right. So as long as this number that's being raised to the x is bigger than 1, you're good to go. All right. And notice it's exponential because the letter x is an exponent. So then that also brings us to the decay feature. All right, so the decay feature must also be exponential. All right, so it has to have x as an exponent. All right, that's what makes it exponential. But then for it to be decay, the number that is raised to an exponent is between 0 and 1. All right, now you don't want a negative in there, okay? Having a negative inside of an exponential decay function, it doesn't work. All right, so you can have like 4 to the point, or times 0.5 to the x. That's decay. But if you see something like y equals 2 times negative 3 to the x, that is not decay. All right, putting a negative in there messes up the whole function and it gets real messy. Okay, exponential decay, just keep this value here between 0 and 1.